Hi, welcome to the OPOLab, the OSSD Grade 10 NPM 2D, Chapter 3, Graphs of Quadratic Relations, Section 3.3, Factor form of quadratic relations. So this section we're gonna talk about what's the factor form and draw the graph according to the factor form. First, let's see the general way. So what's the vector form? Vector form is it can be written as the y equal to a times the, for y is x minus r and the second term is x minus s. So this y is called the vector form. Okay, but we need to make sure that the m cannot be 0 and r is master. Well, a cannot be 0 if when a equal to 0 or 0 cause this term will can be 0, so it when 0 times the a it can be nothing. Okay, in this case we're going to talk about where the mass can be 0, but in this case we're gonna talk about where r is greater than 0. For this for we to talk about it. First, we're gonna talk about the x and y at set. Because the vector form we don't need to talk about the y at set, only for the y at set. For what? So yeah, vector form the x at set is to find the root. The roots. What I mean? The roots is gonna like the way this time equal to 0. So that means where because with the at set that means for y equal to 0. So we just to make sure that for this formula equal to 0. Okay. So now we can find the two form where y is the x minus r equal to 0 or x minus s equal to 0. So the xy equal to r, the x second equal to s. So we find the two at set of the y is r0 and the other one is the x equal to 0. So that the two at set of the vector form. Okay, let's see the first example. First, we just to find the at set. We just to measure that where this time equal to 0, so we can know that the x equal to 2x equal to 8. So for y is the 2, 0 and the second is 2, 0. Okay. For next we do the same product, same steps. This y equal to 0, so xy equal to 3 and second equal to 5. So it's gonna be that 3 or 5, 0. Okay, the next one is for the next one is the vertex form. So how to find the vertex form for the vector form? So it's the same step for the last section. So in this case we already find the two roots, so we just to plus them together and over 2, right? And we can put the and we can put this formula to here. So we can measure that where A2 times R plus S2 minus R times R plus S over 2 times S. So let's do an example. So for vertex, that's going to do that for 2 plus 8 over 2 equal to 5, and we plug it to the form. So it's going to be 5 minus 2 times 5 minus 8 equals to negative R. So the vertex point is the 5, negative 9. Okay, for this one is the 3 plus 5 over 2 equal to 4, and for 4, and we plug it to the original form. It's the 4 minus 3 times 4 minus 5. So it is equal to be 1 times negative, so it's 1 over 2. Okay. Okay, so I think we need to talk about the y set. So how to do y set? We just use it for when x equal to 0, so it's gonna be for a times for a times 0 minus r times 0 minus s. So it's gonna be ARS. So the y set is equal to 0 and a times r times s. So for this one is the 0 times 2 and times 0 times the 8 equal to minus 8. So it's going to be negative 2 times the negative 8. So it's going to be 16. So the y set is 0, 16. Okay. Now I think the final step we can draw the graph. Okay. So for the graph, it's gonna be like that. We can put this number to the R and this number to the S. If the where a equal greater than 0, it will be up down. It's gonna be like this. If we are a to 0, it's gonna be like this. So let's do a problem. So for this one, we can already find these 4 points. So we can easily draw the graph together. So this one is 2, this one is 8. The y set is 0, 16. For the vertex is 5, negative 9. One, 2, 3, 4. Okay, so now we have already two. So, right. Okay, let's do the next one. For 3 and 5. On why we have already, we do not solve the white set yet, but it's easy. For just like for 0 and for ARs, that means maybe the next street, so it's gonna be 15. So for this one is the 0, 15. For the vertex is the for 2, for -2. This is 4, and this one is the -2. With the graph, it looks like that. Okay. That's the end of this